Hey, good morning. It is going to be Tuesday when you hear this. This is 11.3 and 11.4. And we're not going to spend a lot of time over 11.3 because there's not a lot of typical application uses for this other than architecturally. So it is kind of neat to see how some of these things are done. So I'm going to go ahead and show you 11.3 and give you a few problems from 11.3, and then we'll get into 11.4 and do a few more problems. And then that will be what we're doing this week. Again, as you're listening to this, I want you to understand that if you have questions, I need your questions by noon the next day. In this case, it will be Wednesday. And then I'll answer those questions if you have them. And then all of the homework, 11.3 and 11.4, all together in pictures sent to me by 2:30 on Thursday. All right. And again, stay tuned because I'm going to tell you what the homework assignment is, which is going to be shortened. All right. So here we go. On 11.3, we're going to start out by finding areas of kites and rhombus. So the area of a kite or a rhombus is equal to 1/2 your diagonals multiplied together. All right? Okay, so let's take a look at number 4. Number 4 is a weird-looking kite. Okay, and there's a diagonal there and a diagonal there. So this is 6 units, and that's 6 units. And this is 2, and this is 10. All right, so now what are the diagonals? So the area is going to be 1/2. The first diagonal, we'll do this one right here, the horizontal, is going to be 12. And the second diagonal, and we'll do this vertical one here in red, is also 12. Okay? So now let's calculate the area of that kite. So 1/2, and 12 times 12 is 144. And 1/2 of 144 is 72 square units. Again, it's an area, so it's squared. All right, 72 square units. Now, let's do another one. So this is going to be number 6. And this looks like this. See if I can get this right here. Draw these diagonals. And this outside one is 5, and it has these hash marks on it. So that should tell you right there that it's a rhombus. All the sides are the same. And then it has this value here, 6. And that is the same as your diagonal there. All right, so the area of this rhombus is still 1/2 the diagonal times the other diagonal. So 1/2. And the first diagonal, we'll just go ahead and do this one right here. That matches that. That's 6. And then the other diagonal is this long one here. So how are we going to figure that out? Okay, so notice this is a right triangle. That's our hypotenuse. If the whole thing, this whole yellow diagonal is 6, that means this piece, this leg, is 3. So we need to know the red piece, which is going to give us half of that red diagonal. And notice it is a triangle, a right triangle. We could use the Pythagorean theorem, and you should know that this is a Pythagorean triple, which now makes this a 3, 4, 5 triangle. Or you can use your Pythagorean theorem and figure it out. But that's a normal 3, 4, 5 right triangle. So our red diagonal is actually 8 units from corner to corner. So you do have to do a little calculation of trying to figure these things out. So the area is going to be 1/2. 6 times 8 is 48, which is 24 square units. All right, so you multiply your diagonals together. You got to find whatever those lengths are and multiply them together, and then you take half of it, and that's your area of your triangle and your rhombus. So now let me move this up here and give you what I want you to do for your homework for 11.3. Very, very short. So your homework is going to be on page 614. Remember, you got to listen to 11.4 as well because I want you to put them all together. Page 614, I want you to do number 3 and 5. And you have the answers, so you have to show me your work. Show me your work and don't copy off of each other. All right, this is really simple stuff. All right, so that's your homework for 11.3. Now let's talk about 11.4. And let me move all this stuff up and get started here. Oops. Okay, in 11.4, this is about identifying three-dimensional figures. So it's really simple. I'm going to need is the names of the stuff. So I may give you an even problem to do just to see what you have. But I want to point out something specific, the differences, and try to get you to understand this. So what's the difference between a prism, and a pyramid? Well, most of you understand what a pyramid is, but we get these things messed up a little bit. So a pyramid kind of looks like this. I'm going to draw something here with a square base and connect those corners. The dotted lines mean that's what you can't see. It's behind the front of the picture. So that's a pyramid. Well, if I draw a square prism, then what I'm doing here is drawing a top and a bottom square, top and bottom. And again, the dotted lines represent what we can't see. Notice the difference. So a prism has the top and the bottom being identical. A pyramid comes to a point, which you all understand that very well. But how do we name these? We name these based on the shape of their bases. So if I put a little 90-degree mark there, this would be a square pyramid. And you got to have both of these words. This, if I put a line there for 90 degrees, and I say that these are equal sides, you know that's a square as well. Okay, so this would be a square prism. Now it's important to be able to name these because to be able to come up with the volume of what's inside, you got to know what the shape of the base is. So this is an easy lesson to know the names, but don't take it lightly because pretty soon I'm going to ask you to find the volumes of these things, and if you can't identify what the base is, then you're in trouble. Now, one thing I want to point out about the prism is the sides of a prism are always rectangles. So if I look at number 4 in my book, the top and the bottom are pentagons. It's a bad looking pentagon, but regular meaning all the sides are the same. So a pentagon, and the bottom is the same. So I'm going to draw my sides, which gives me rectangles. Notice there are rectangles. And again, the dotted lines are what you can't see. But the point is showing you that the top and the bottom are identical and the sides are all rectangles. Now sometimes they have these tipped over on their sides, which makes it difficult to see. But the difference between the sides and the top and the bottom is that the sides are always rectangles and the top and the bottom are whatever shapes they are, but they are identical shapes. And then obviously the pyramid, the sides of the pyramid are always triangles. Okay, so what would I call this? I would call this a pentagonal prism. You have to have both words in your answers. Okay, so you're just giving me these things. So let's do another problem here. Let me move this up, and we'll try something else, see if I can do a fairly decent job drawing this. Okay, so I'm going to show you number 10, see if I can draw this here. And I'm specifically choosing this on purpose. So I have this shape here, and I'm going to draw this back this direction. Okay. All right, so now the question I have for you is, what is this? First of all, it's not a pyramid. And you say, oh, it was a pyramid, they cut the top off. No, that's not. if you notice, the front and the back of this, I'm going to draw this in blue, the front and black are both trapezoids. They are the exact same shape. And what did I say about prisms? You have to know what the bases are. So a prism has two bases, a top and a bottom, or a front and a back. And notice that the other sides, what are the shape of the other sides? This is a rectangle. Rectangle on the top, a rectangle on the side, and a rectangle on the bottom. So the sides are all rectangles, and the front and the back are trapezoids. So what do we call this? A trapezoidal, prism. Prisms have a top and a bottom or a front and a back that are identical, and rectangles for the sides. All right, one other thing. These are called polyhedrons. A polyhedron has polygons. Polygons are, a triangle, a square, rectangle, pentagon, hexagon, heptagon, octagon, nonagon, decagon, 11agon, dodecagon. Those are called polyhedrons, meaning they're all straight sides. A cone is not a polyhedron. Okay, so I'm not asking you that on this one, but I just wanted to make sure you got the names correct when you're looking in the book for what these are asking. Okay, so again, how do we name these? You have to identify the bases. It's either a prism or a pyramid. I don't think you have any problems with pyramids. But the prisms are harder for students because they have a hard time understanding the front and the back or the top and the bottom. Okay, just remember the sides are always rectangles. Don't use the sides to label it unless you actually have a rectangular top and bottom for the prisms, okay? So you are going to have to name these. So here's your homework for section 4. So this is going to be on page 621. Remember, this is important that you identify these correctly because we're going to be doing volumes, and you have to find the volumes of these different shapes. So page 621, you're going to do 3, 5, let me see here, 3, 5, 7, and 9, okay? 3, 5, 7, and 9. And I want you to do one even one, and obviously I'm going to be looking for this one. The odds you have the answers to, so I expect you to look at those. I don't need to look at those, but I am going to make sure I see your work done on the other assignment 11.3, and I am going to make sure that I see that you've done these. And I want you to do number 8 as well. So pretty easy assignment this week. Again, if you have questions, go to, make sure you email me your questions by noon on Wednesday. I'll answer them if there are any. And this is all due by 2:30 on Thursday. Don't waste your time. Have a great week.